Okay, in today's lesson, we're going to learn about scientific notation. This is 7.3, section 4.3 in your book. Scientific notation just states that if I have a number between 1 and 10, I multiply that by a base 10 to any exponent. Okay, so our base 10 is just going to tell us how many zeros or decimal places we're going over. So our first number we have, let's take example 13. Our number is okay, if we want to write this in scientific notation, we have to make sure that our first number is between 1 and 10. Okay, so we're going to take our first number. We got 5. 5 is between 1 and 10, so we're going to put a decimal. And then every number past that till you run into a 0. Okay, now we're going to go times 10, and our exponent here is going to tell us how many places to go over from the decimal. So we put a decimal right here. We're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to put a 9 for our exponent. Okay. If your exponent is positive, the number is big. Okay. Example number 2 here, we got problem number 17. Okay, 0. Okay, so we still need to find our first number. It's between 1 and 10. So I go over and I look, where's my first integer here? My first non-zero number is 7. So I'm going to take that 7, multiply it by base 10, and I'm going to count how many zeros I go over from my new decimal point. So I go 1, 2, 3, 4, 5, 6. So I have 7 times 10 to the negative 6. Okay, our negative exponent makes the number smaller. Spelled number wrong. Okay, so if we have a positive exponent, we're going to get a big number. If we have a negative exponent, our number is going to be somewhere between 0 and 1. Okay, so let's try to go the opposite way. Let's try to take a number in scientific notation and write it in standard notation. So 25 in our book, we have 7.5 times x, just kidding, 7.5 times 10 to the 5th. So this is great. This is between 0 and 1, right? So it looks just like our formula up here. So I write out 7.5, and this is telling me to go 5 zeros to the right. So I'm going to make it bigger. 1, 2, 3, 4, 5. I like to count out 1, 2, 3, 4, 5. Okay, so this is our new decimal point. So my number is 7, 5, 0, 1, 2, 3, 750,000. Okay, if we're going to do a negative exponent, like example 33, we have 7.8 times 10 to the negative 4th. Okay, so my negative tells me, my negative exponent tells me I'm going to start with 7.8. Okay, and this is telling me I'm going to the left 4. I'm going to make this number small. 1, 2, 3, 4. So I get 0.000. Okay, if I rewrite that, 0.123448. All right, moving on to multiplying and dividing. So example 43, we have 5 times 10 to the 4th multiplied by 3 times 10 to the 2nd. Now let's remember that if we're multiplying 5 times 10 to the 4th and 3 times 10 squared, and these are being multiplied, we we can move our 5 and our 3. Okay, that's our commutative property. So I can go 5 times 3 first, and I can multiply 10 to the 4th times 10 squared. Okay, 5 times 3, 15. Okay, times, these are both base 10. So from our exponent lesson, if we have two of the same bases, we can add the exponents. So we have base 10, 4 plus 2 is 6. Okay, we're not quite done yet. 15 is not in base, or does not have, it's not between 0 and, or between 1 and 10. Okay, so we have to make 15 between 1 and 10. Right now we have a decimal point right here, and we need to move it to the left one. Okay, so 15 can be written as 1.5 times 10 to the 1. We're still multiplying times 10 to the 6. For your first couple, you guys, I would definitely write this out. Okay, this is where most people make mistakes. You're moving 1 to the left. Okay, it's getting bigger, you need to add there. So 1 plus 6 is 7. So our answer is 1.5 times 10 to the 7th. Okay, on the same page as multiplying, we can divide in scientific notation. So example 51, we have 9 times 10 to the negative 5th divided by 3 times 10 to the 3rd. Since these are being multiplied on top, these are being multiplied on bottom. Okay, we can use our associative property again. We can go 9 divided by 3 times 10 to the negative 5th over 10 to the 3rd. Okay, 9 divided by 3 is 3. 10 to the negative 5th divided by 10 to the negative 3rd. Remember our exponent rules. If we have a fraction here, we're going to subtract our exponents. So this is saying 3 times 10 to the negative 5 minus 3. Negative 5 minus 3 is 8, negative 8. So 3 times 10 to the negative 8. Okay, we got one last problem for today. It's a nice big giant one. It's number 69. So let's say we have 65 times divided by another small number, 1, 2, 3, 4, 2. Okay. The easiest way to go about this is to change all of our numbers into scientific notation. So for this first one, I'd write 6.5. From here, I got 1, 2, 3, 4, 5, 6, 7, 8 places. So times 10 to the 8th. Inside our parentheses, we go to the first non-zero number, 3.2. Now I'm going to count back. 1, 2, 3, 4, 5, 6. So I got 10 times 10 to the negative 6 all over, go to the first non-zero number, I got 2 times 10, 1, 2, 3, 4, 5, times 10 to the negative 5. Okay, since everything on top is being multiplied, everything is is being multiplied, we can rearrange this. So you can go 6.5 times 3.2 divided by 2 times 10 to the negative, to the 8 times 10 to the negative 6 all over 10 to the negative 5th. Okay, 6.5 times 3.2 divided by 2. I'm going to do that over here. 6.5 times 3.2. 12, 13, 0, 15, 18, 19. Okay, 2080, I have 2 decimal points. So 20.8 times 10, 8 plus a negative 6 minus negative 5. 8 plus a negative 6 is 2 plus 5 is 7. Okay, 20.8 times 10 to the 7th. Now remember, I'm not quite done. This 20.8 needs to be between 1 and 10. So I have to shift this over. 2.08 times 10 to the 1 times 10 to the 7th. If I add my 1 and 7, I get 2.08 times 10 to the 8th. I'm going to double check my answer. Ooh, I goofed. The only thing I goofed on is I forgot to divide by 2. So if I take 2.08 and divide that by 2, I get 1.04. Okay. So my answer is going to be, sorry I ran out of room, 1.04 times 10 to the 8th.